So what is ALERT and why is it important? ALERT is the standard that we use that was developed by the National Weather Service for sending flood data over the air via radio. It's been around for quite a while and has finally gotten an update in the last few years. So our flood detection system, which is based on the ALERT, we use that and support flood response, emergency action plan, and identify hazardous areas that may require evacuation or hazardous transportation routes that may require closure. So that's kind of our writing mission. I'm going to ask to mute their phones so that we don't hear stuff going on your end. The ALERT system itself starts out up here with the stations that are out in the field. This is a weather station. It's got some arms with sensors for different things and rain gauge on top. We're up to 371 now with 323 rain gauges and over 200 water level gauges and 38 weather stations, and all that information may or may not go through a repeater site, but it goes to three places. It goes to our County Department of Emergency Management, where we have a backup base station. It goes to the National Weather Service in Phoenix and the Arizona Flood Warning System, so that's at SRP's building. And then it comes into our ALERT room. It's available immediately over the internet to anyone who wants to view it. We can view it and make changes to things from home over remote PCs. And of course, there's a mobile phone component now that is really nice for folks out in the field. So here's the current distribution and the types of gauges that we have. Many rain gauges by themselves. Stream and stage gauges. So in our nomenclature, these are both sensors that measure water level. The stream gauge is on a flowing stream, and a stage gauge is on a static pool. So a dam or a basin would have a stage gauge, where a creek or a river or arroyo or whatever has a stream gauge. And then a few configurations of weather stations. ALERT, and we're going to call it ALERT1, the old ALERT, started in 1978, which was almost 40 years ago. It used VHF and UHF radio frequencies, which we still use today. And to operate on those frequencies, we have to get a letter of approval from our local National Weather Service office. Old ALERT transmitted two things. It transmitted an ID number for the sensor that collected the data and the actual data number, both of which were integers. So the data number had to be converted from some integer to something meaningful in engineering units like feet or degrees Fahrenheit. And in old ALERT, the data was time-stamped by the base station. So it wasn't the actual time that the sensor was read. It was some number of seconds after that, once it made the trip through the repeaters, through the data decoder, and into the base computer itself. Well, this is our first ALERT system in the old building, our big refrigerator, computer, and a console that had no graphics, just tabular outputs. So we've come a ways from this, as you'll see. So in 2001, a committee of ALERT vendors and people who use it formed a committee to develop this new ALERT2 standard. It was were studied in 2002, and there were working hardware and software prototypes by 2008, and it's been field tested since 2010 by several agencies, not just us. So what's different between the two? ALERT2 uses now, instead of an ID for every sensor, the station itself is given an ID, and each sensor at that station has an ID, and the two of them together identify where the data is coming from and what sensor. So the station ID range, which used to be devices from 0 to 8,000, is now 1 to 65,000. In Maricopa County, we're using stations that are numbered from 50,000 to 5999. Other counties in Arizona are using 51,000, 52,000, 53, 54. So anywhere that this data ends up in the United States, if it has a 5 in front of it, it's coming from Arizona. And I'll show you how we arrive a little bit later. So each station then can have up to 256 devices plugged into it. I think we've used device numbers up to maybe 21. The first 10 of them or so are pretty standard, like the rain gauge is 0, and the water level gauge is 7, and the battery's 8, etc. The old data range was 0 to 2047. Now we have 2 billion negative on one side, 2 billion positive on the other side. To the end user, whether it's inches of rain or feet of water or degrees Fahrenheit or solar radiation in watts per square meter, the data is not going to look any different. But the underlying way that it gets here is much more sophisticated than it used to be. So we converted most of our system to ALERT2 because ALERT will not be supported beyond 2020. So the manufacturer of parts and software is going to pretty much halt by then. The transmitters in the field now have their time set from a GPS lock. So every transmitter has the same time. The repeaters have the same time as each other. And we use a scheme called TDMA, and I'm not going to say what it is because I can't really remember it even. But what it does is it allows little chunks of time for each station to transmit. And the repeaters especially, the repeaters each minute get a little time slice, and then only that repeater transmits during that minute. So it way reduces the amount of data collision that we used to get. I mentioned the station ID range is greatly expanded. That's been very helpful in California, where they have many systems right backed up against each other, and they were running out of IDs. We also, in the field, at the transmitter, have the choice to transmit raw data like we used to, or data in engineering units. So we can transmit now data with floating points and that kind of stuff, and makes it a lot easier for others who may be looking at it to interpret what it is. So our conversion process was to, first of all, install the base station software that can read ALERT2 format. And we had to install new radio receiver decoders. We've done that at Durango. Again, we have the decoder, we just haven't installed it yet. All the repeaters converted. And we had about 350 stations to convert. So I mentioned before that we were up to 371 stations. Well, those 21 additional stations have been installed as ALERT2. They never were ALERT1. And we only have 16 conversions left to do. So we should be able to finish before the end of the month if things go well. Here's a look at an alert transmitter. This is what fits in the tube and is stored basically underground when we bury the tube. One side of it has the old computer board with the plug-in for the serial cable to program it and that type of thing. And then on the back now is mounted this board which does the ALERT2 stuff. So to convert an old transmitter, we just have to install this new board on the back and make some changes to the programming, of course. This little box down here is the radio that sends the information out. So this is kind of what the new map looks like with these alert source addresses or the station IDs. Like I mentioned, all of ours start with 50. And they basically then the last 3 digits go up from 1 to 999. And we put space in between the existing ones, so when we go to install a new station, we can have the ID number kind of match where it might be. Like if we were to put one right here, we might call it 50452 or 83, so that it kind of fits in the name in the numbering scheme. One of the other nice things about ALERT2 is there's a national website that was created to inventory all the ALERT2 stations in the country. And that's at alert2.org. If you go to that site, it will bring up a map that shows where the different alert systems are in the country. And as you zoom in, you'll see all their ALERT2 stations. There's 45 agencies right now that have ALERT2 registered sites on this site. There's a login and password, and we can go in and add addresses. So this is the latest one I did, the one at US 60 at Gold Canyon. Well, it just asks for the source address, what type it is, whether it's a repeater, a decoder, or a site in the field, and then the latitude and longitude. When you input that, it will look around and see if there are any other ALERT2 stations within a mile radius or several mile radius of the one you're looking at. Not so important for us here in Maricopa County, but in other places like Texas and California where they have alert systems bumping into each other, it helps make sure that the source addresses don't overlap. And that's pretty much it for ALERT2. Does anybody have any questions for me before I go on to the next presentation? Hearing none, well, I'll do the next one. Okay, I want to touch on something that we're doing to update the rainfall records. If you go to our website, fcd.maricopa.gov, and go to the rainfall page, down here under rainfall history documents, you can pull up a document for each rain gauge that we've installed. And that document currently looks like this. So it's a Word document converted to a PDF that has the picture and the map and some statistics about where the gauge is and what its elevation is. It has a table of annual precipitation values and some statistics on its heavy storms, and the annual table down here, and a link to the NOAA 14 precipitation frequency estimates for that point in space. And then for each year, a summary of the daily values and some statistics on the daily, monthly, annual, and number of days with rain. If the gauge was down during any time of that year, there will be a footnote down here explaining the time that it was down, why, and whether or not rain fell and affected the record. The problem with this document is that to update it each year, I have to go through a lot of pieces from other documents. I get things out of Excel, like this plot. I get things out of Access Database. I have to run a report on the alert system that generates this piece right here. And then I add a page. So for 2016, I would put a new page here. Well, some of these guys are getting over 30 pages long now. I believe this one's 36. So it's getting kind of cumbersome to update, and it's getting pretty cumbersome for the user. So I've come up with a new format that uses Excel, and it looks like this. So Dan asked me to maximize the screen to help you all see this better. All the components that you saw in that other PDF document are here, except that a lot of the mathematics is done locally, and the graphing is done locally, so I don't have to go from Excel to Word. It's all here now. So the average annual for the number of complete water years is right here, and that's calculated by the sheet. Under the remarks, there's now a pop-up that explains what a good record is versus a fair record versus a poor. On the plot now, the blue bars are the water year totals, and the red bars are the monsoon totals. And in a lot of cases, if we install a gauge and don't get the complete water year, we can still get a complete monsoon season. This is just the period June 15th through September 30th. The numbers that go into making this plot are over here. And it shows the last day that it was updated. This sheet is protected. If you look up here, you can see that everything is grayed out except for a couple of things that you can do. But the real beauty of it is on this page, the annual tables. So before, where we had a sheet for every year, now there's just a pull-down list, and you can pick out a particular year, and it will grab all the daily values for that year. And the statistics down here change. I've added the monsoon total to those other statistics. The downtime footnotes now are on a page by themselves, so they go in descending order of time, and there's even a calculator for the total number of days down. So the station was down 25 days out of 32 years of operation. That's not too bad. And on here are the actual daily values. So remembering that the water year starts on October 1st, 2014, it goes all the way down to 9/30 of 2015, and it sums the annual total and the monsoon total. That exists for every year that the gauge was in operation. If you want to print this page, it's already set up dimensionally. Or the big sheet here, I believe, is no, it's 8.5 by 11. I was going to say 11 by 17. Same thing for the annual tables. Go to prints. Gives you a nice on one page. I'm going to open one more just to show what a short record looks like. So here we have just 6 complete years. So the plot bars are a little bigger, and as years are added to this, then of course the bars get shorter and they fit into the graph. So I have about 120 of these completed, and it's going to take me several more months to complete them all. And then I'm going to port them over, and they will show up on the website under this pull down, just like the PDF documents do now. So any questions about the annual rainfall summaries? Hearing none, I will turn this over to the person who's next on our agenda, which is who? Dave. Which is Dave. Okay.
Well, good morning. I'm David Gardner, and I am the senior hydrologist, the flood warning branch here at the ALERT group, and my primary job is to operate and maintain the stream gauges. And there's a lot that goes into that, and what I'm going to show you this morning. Just briefly talk about the current stream gauge statistics, just the numbers we have, and give you an idea where they're located. Talk about the web products review, just go over some things that are on the web that you probably have seen, but might be good to get a refresher with. And then I'm going to show you what actually goes on out in the field, what we do to prepare for the monsoon season, and just all the things that are perhaps out in the field that you may not be familiar with that actually generate and produce all this data that you see. So let's go ahead and get started. So for the FCD stream gauges, the current count, we have 202 total sensors out in the field. Of those, 132 are on stream gauges. 64 of them are on dams and basins, so they're just recording level, not necessarily a moving stream. And then we have 6 status sensor locations. And some of these are combined that have stream gauges and status sensors. There's a few that are just status sensors, and the dams are there by themselves. We did install within the last 12 months 17 new stations, with 15, I believe 15 of those were in the city of Phoenix at their request, and there's a few others that have been installed as well, but the majority of them were in the city of Phoenix. And just kind of as an aside, we do operate stations, mainly in Maricopa County, but there's also some in La Paz County, Pinal County, Yavapai, and we have one lone station right out on the border of Yuma County with Maricopa County. So we do operate stations, various locations, not just Maricopa County, but it's whatever drainage area affects or water would come into Maricopa County and affect the citizens of this county, that we would have a station outside the county. So I came up with some photos here. Found 14 of the 17 new stations that we installed. Just put a quick overview of them up here. Most of these are the city of Phoenix ones. This one is Twin Buttes Wash in the city of Peoria. These 3 here are on the new Skunk Creek gauges. This one here is at the Phoenix Zoo. We installed, this is Zoo Dam number 3. We installed 2 different gauges there at the zoo. This is the only one I have a photo of, but One is inside the zoo. This one's just outside the zoo boundary on one of the fishing lakes that are out there. And here's a map that shows where the stream gauges are located. The red dots are actual stream gauges, with the blue dots being impoundment gauges, whether that be a dam or a basin somewhere. So you can see they are scattered quite around, with the majority, of course, in Maricopa County, but some in Pinal County, some in Yavapai, one in La Paz, and one, like I said, right on the border with Maricopa and Yuma County. Let's look at what information is on the website, now that we've looked at just kind of the number and locations of the stations. Each station, each stream has a unique web page for it. They all look like this. I'll give you a close-up view of this shortly. But they all look like this, whether it's a stream gauge or a basin gauge. Each stream also has a graphic that will look like this. Again, I'll give you a full screen view of it shortly. But this will actually change when flow is occurring. So you'll see that kind of be dynamic as it goes through time. So, and the final thing is the Google Maps. It gives you access to these pages and much more. So let's look at this. So first, this is where the locations of our information on the internet is. This first one is the main flood control district web page. From there you can get any information that goes on at the flood control district. This second link is to the Streamflow page, the main Streamflow page itself. And then this last link would be to the Google map, just the general overall Google map. And we're going to start out at the main page, main flood control page, and show you from there how to get to the Streamflow information. So we have the main page. This would come up like this if you typed in this address, fcd.maricopa.gov. And down here at the bottom, you might have to scroll depending on the size of your screen, but there's this thing that says find current and historic rainfall and stream data. And if you were to simply click on that, you would come to the main page, which is the default page that puts you on the rainfall data page. And from there you can go two directions to get to the water level sensor data. This first one's just a direct link to the page itself, which will look more like this one here. Or you can simply click on this, just anywhere on the map here, this Google map, and it will bring up a page that looks like this. Won't have any data on it particularly. The screen here will be clean, but it'll give you a menu of things to look at, or things to choose, I should say. And so if I was to choose the impoundment data, that's what we're going to look at. If I was to click on that, I would get some impoundment information. Now here I've zoomed into the Wickenburg area because we're going to look at one of the stations out in Wickenburg. But we have 3 dams out in Wickenburg, Sandro, Sunset, and Sunny Cove. So we're going to look at Sunset FRS today. So if we wanted more information about this, I would click on this number here where it just says 0.0. Right now it's indicating, obviously it's dry, so there's no flow out there, there's no impoundment out there. But if I were to click on that, I would get this small pop-up that comes up, and it gives me some choices over here, and it gives me some brief information. I'll get a small table that will show me what's going out there currently, current stage, current flow, capacity, and drawdown time, and then a graph of where it is currently, what may have occurred previously. So kind of like a hydrograph there. I'm not going to show this one to you, I'm not going to pop this one up, but if I was to click here where it says last 125 reports, it would just show a table with just a very basic table of the last 125 timestamps and data points that would come up. But if I were to click any of these other three, current conditions, view impoundment page, or decision support page, I would get this popping up. They wouldn't pop up like this, but they would pop up individually. So I wanted to show you all three on the page itself. So this first one, current conditions, I showed this one to you a moment ago. It just gives you a live graphic. It's dynamic, it changes as conditions out in the field change, but it also gives some other information. Again, I'll go into this a little more detail here in a moment. The main impoundment page, showed that to you as well. We have one for each gauge that's out in the field. And also something that's available for all the impoundment gauges currently and for all the stream gauges. Some of them currently, but they're still in progress. Not all of them are available yet. There's a decision support page, and I'll talk a little bit about that here in a moment too. But this is what you'll get if you choose any one of these, click on any one of those in that pop-up that comes up. First, let's look at the page that comes up for the dam and for any stream gauge that we might have. So this is the general format for any stream gauge, any dam or impoundment gauge that we might have. And just it's a very basic layout, but it's functional. It gives you the opportunity to grab and select data and import it, or even copy paste to Excel. But we have some information here. We got some pictures that'll scroll through. We have a Google map of where it is located, and you can click on that and get a larger map, or click here to get a larger map. Some things here up on the top. These are all links to more information. The current of the gauge is just that dynamic page here. We just pop this piece up here. Station description is just a document that would give more information about what's specific to that particular gauge station. Q rating curve, so the discharge rating curve, the volume rating curve. If you want to look at those, just click on those. That would come up, as well as the tables. Click on those. You get just a tabular of the rating values themselves. And then for some, we do have some dam break information that was done on some old studies in the past. And it comes up some graphic information as well. But throughout the page, we have gauge ID history, how it's changed over time. If we scroll down, more basic information about the site, where it's located, spillway, top of the dam information. Down here, we have a brief rating. It gives different heights and what the discharges would be, or the volume would be at certain elevations. Water peaks, water year peaks, they're available there as well. So if you just want a quick overview of what has happened each year, that information is there as well. And scrolling down further, all the impoundment event history is available. I could scroll further down. Gauge has been there 25 plus years. So there's a lot of events that have occurred, but all of them are tabulated. This is very easy to right-click, select it, and import it, or copy and paste it into Excel for further analysis if you're interested in that. So just want to make you aware that that is there and that's available to you. Back here near the top, these links here just link to the things down further in the page. So these are kind of external documents where this just links to the page. So let's go a little farther on here. Talk about this live dynamic graphic that we have. This part in the middle, this will actually change as the level in the dam would rise. So back last year on July 18th, this thing here would have been full. It would have, up to this point here, so it would have been filled in with just kind of blue color to indicate the level of the dam. Gives you different alarms, different points of where the dam is. far as stage in relation to the emergency spillway, we have some information, just some basic information over here, top of dam elevation, spillway elevation, and then where is it related to the zero gauge height. Most of our dams, the zero gauge height is related to where it can flow into the outlet, the invert of the inlet, I mean, or it could be related to the staff gauge. They're usually pretty closely related to one another. So there's a lot of information available here. We have the ungated outlet elevations as well. And then current conditions, these will change as well. All these will change as conditions on the out in the field actually change. And then again, some hydrographs that will show what's going on. And some basin rainfall. This is rainfall information that is current to just the the basin, whatever affects the watershed for this particular dam. So there's a lot of quick information you can get just looking at this. And then, as I mentioned, the other thing that's available there is the decision support pages. It shows the basin here, just kind of gives you where it's at, where the dam is located in relation to the drainage area. We look down farther, we have the events of July 18th last year, how much rainfall fell, how quickly the dam filled, and just some information about it. It got up to almost 75% of capacity that day. So it rose quite rapidly. So just what the decision support page is there to do is just give some historical background of information, historical events, so that you can look at it compared to what's going on currently and say, hey, this is similar. We have similar rainfall patterns. We have other things that might be related to what's happening currently, so that you can say, hey, this might be how this dam responds at this time. So it's just some more information that we're putting together to give you more tools in which to make decisions, to just kind of get a handle of what's going on out there. So that's available to you as well. Just wanted to briefly show you the Streamflow. If I had selected, instead of impoundment, I had selected Streamflow, I would have gotten all the Streamflow gauges. There's 132, so there's about twice as many stream as dam and impoundment gauges are. So, but they're clickable as well. They have the same things available to them: the reports, current conditions, Streamflow page, and a decision support page if it's available. They're still in progress and working on them over time. So again, those same tools are available for both the stream and the impoundment data, or the impoundment gauges as well. So that's that. As far as what's available on the web, just kind of a summary. There's a lot of information available to you, a lot more than what I showed you. Please take the time to look through what's available to you. Get familiar with it. We take a lot of time to put it together, and it's for your use, for your benefit. So, but if you need assistance, feel free to contact me. I'll be more than happy to walk you through it or answer any questions you might have. So that takes care of the web. What I want to talk about next is, what actually goes on at an alert gauge site. Sometimes you find a snake eating a snake, but don't find that too often. But that's not usually what goes on out there. So what we're going to show you is a couple of structures. We're going to go back to Sunset FRS and show you that as one of our impoundment gauges. And this is the pool side of the gauge. This is the outlet structure. We have some staff gauges here on the side. There's another staff gauge here. We have the alert tower, the alert tube up there on top of the crest of the dam. The spillway is here. And down here, it's not very visible, but our level sensor, our pressure transducer, is located near the bottom here. So that's what's out there at Sunset. This is from just the side of the view here, the side of the outlet structure. We have the lower ungated outlet. We have the upper ungated outlet. So there's two of them here. And this is just the top intake tower. Again, this is the pool area behind us, or actually here in front of us here. Our staff gauges, we go all the way up to the top of the dam. So just a reminder, and when reading staff gauges, most of the time, virtually all of them we have, the elevation is at the top of the number. So 4 feet is at the top of the black square with the 4. So if you look at that here, 4 feet, you'd read it right there. That'd be 4 feet. 3 feet, so anything in there, you estimate the tenths of a foot. So, but that's how they're read. So the top of this is 5 feet. So just kind of a reminder, if you're ever out looking at staff gauges, that's what that's how they're read. Let's take a brief look at a stream site. I meant to put the name on this one, but this is Picacho Wash, about 10 miles west of US 60 along State Route 74. And we're going to look at 3 different things here. We've got the ALERT tube, of course. This is a Crest Gage, and down here, not visible in this picture very well, but that's where the pressure transducer, our level sensor, is located. That sends us back real-time information. So more close-up, we got the Crest Gage over here and the transducer gauge over here. So I visited this site on Monday of this week, and I found a flow event had caused both the Crest Gage and the transducer to be somewhat covered in sediment. So I showed the shovel here digging these 2 things out, getting them ready for the monsoon season. As you can see, they're both dug out at this point. Got some tools here ready to service them. I took the pressure transducer apart. We looked at it, found it kind of dirty, and so I thought we need to clean it up. So the top right here, same picture you just saw, transducer was dirty. I've taken a little bit of water, got it cleaned up, got the inside of this thing cleaned. There was some little mud caked inside of it, so got that taken care of. And ready for the monsoon season. You know, just a quick picture of what's inside the transducer there. A little sensor way down deep in there. And it's really not that far, maybe a tenth of a foot inside that. But how they work, they just measure the pressure against the sensor. This sensor in here. Pressure is then related to the level of the water above the sensor. And it sends that information back to us, how high the level is in the stream or the dam. And then through mathematical analysis, we can convert those values to a discharge or a volume. And the Crest Gage, took that apart. There's a stick inside that, 4-foot stick. It's about 4 feet long there. We put ground cork in the bottom of it. It floats up with the water level, leaves a mark on the stick, and then we can take it out and measure it. And after the event, go back and verify that, yeah, the water really was that high. And we can verify it versus our pressure transducer and see how well the 2 match, and hopefully see how well our station is working. A few gauges, like I mentioned, we have some status sensors out in the field. They're inside this. They're usually in an off position. There's 2. It's either off or it's on. Off indicates there's no flow at that level of the sensor, so this one would be here. So there's no, if the water's down here, our sensor would still be off. But until it reaches the sensor in here, it's going to be off. But once the water reaches this, the water floats up the sensor and turns the sensor on. And until the water level recedes, drops that float inside of it back down, it remains on. Once it's back down, it's off. So it's just a very basic sensor which indicates water level present or non-present. And one last thing we do is surveying. Survey leveling is done periodically to ensure proper sensors related to streams and structures. So those pressure transducers, the stream geometry, the Crest Gage pins, all that information is surveyed so that we know what elevations they are, and information that we get back is relatable to other things, and it then makes sense to us. So we do this periodically to ensure things haven't changed as well. So we do surveying out there in the field. So just a quick summary. Significant effort goes into preparing for the monsoon season and maintaining the high integrity and dependability of our data and products. And we really do strive to provide the best products and most reliable data to our customers. And with that, I'll take any questions you might have. All right, thank you.
All right, everyone. We're going to go to a short break right now for about 5 minutes, so I'll put up the rest of the agenda. Let's see, get that up here, and we'll pick back up right at 9:55. So if you need to use the bathroom, get a fresh drink, any of that, go for it now.
What is new with the ALERT interactive data display map? We have a wonderful acronym for this now. So when I say AID map, it's the main map, it's our Google map. So topics that I'm going to cover today, I'm going to review the historical rainfall. We did upgrade that about a year and a half ago, but it's still fairly new, so I want to touch on that. I'm going to introduce the flash flood potential tool. This was in beta last summer, and this year it is up and it's working and it's wonderful, so I want to tell you about that. And then I'm also going to talk to you about future Streamflow improvements, some ideas that we have in the works that are pretty exciting. So first, how to get to the map. You go to the main flood control website. Easiest way is to click on your find currents and historical rainfall. And then you click on this image. So just go ahead and click on that image, and it's going to open up your desktop browser if you're on a computer. It will also open up the mobile version if you're on a cell phone. In the upper right-hand corner, you can also click on that little cell phone that we put there, and it's going to open up your mobile tools, which will get you to the rainfall map if you click Storm Central, and there's also a report of flood in the floodplain map from GIS department. So. Okay, first our historic rainfall map. When you pull up your map, there's a short link on the bottom if you want to follow along. Down here, I want to go to the historic tab up at the top, and there's multiple choices here, but we're going to talk about this overlay. So if you do the get point rainfall data, it's going to just get you these points, and we've had this for a while, but the update to it was to provide this information in an overlay. So all you have to do is keep the same date, time, and time step here, and you can get the overlay. And you can also overlay both of them on top of each other. There is a legend that is on the right-hand side. This example is from July 18th, 2015, so it's Wickenburg. And you can see the overlay, your red over Wickenburg, and then you can also get the point rainfall that's coming from our rain gauges. So how do I get how does the overlay work? Where are all those colors coming from? What we're doing is we're using the ArcGIS geoprocessing service. We use Python, so different code, Python, PHP, and JavaScript to output this overlay. This overlay is not available on the mobile version. You have to be on the desktop version to get it. But what it's doing when it's going out and creating this layer, it's using natural neighbors to interpolate the rainfall totals from the rain gauges only. So it's not using radar, it's just using our point rainfall data from our gauges. So this image over here on this side kind of shows you what these rainfall, imagine these are rainfall totals, and how it's interpolating what fell in between there. So I'll just go back right here and you can just take a look again. So in these areas where there isn't any rain gauges, it's interpreting what is there. So that is our historical data. This is the new flash flood potential tool. This is available on the layers menu. So you just click layers, and then it's underneath the MSP forecast zones. If you notice, they look very similar to, they are the forecast zones, because that's what we're forecasting for. So what is the flash flood potential tool? And I'm going to go back once, just kind of look at this legend here and our zones and see how it's colored. So what this tool is doing is it analyzes the past rainfall to estimate the soil moisture and also the forecast rainfall in each of the district's forecast zones. And it's developed to convey the threat of flash flooding before, during, and after a heavy rainfall event. So if you don't see anything in this none, there is not a high flash flood potential. If it's red, you have a high flash flood potential. So the color scale is meant to easily be portrayed by the public. How is this working? The flash flood potential tool uses multiple technologies. We have to have our alert data. We have to have our rainfall data. Our software, again, it's using a bunch of different coding languages. We use GIS and Visual Studio, and then it needs to be displayed on the web browser. So how does this work? Okay, the quantitative precip forecast is first calculated. So that's what Dan may talk about a little bit later. But we have these forecasts that first calculate for each of the zones using information from the weather station and numerical models. So based on the results of that calculation, each zone is given a flash flood potential classification. The classification is none to high. And then these classifications, as well as the QPF data, are saved in a text file on our web server. So I have some images down here that kind of walk you through, but first script runs, and then ArcGIS processing tools assign the QPF data to a geometry, and the geometry is the forecast zone. And then symbology, which is the legend, is saved in a file, and then the zones get their flash flood potential classification. So this is just the text file. It is blank, but these would have numbers on them for the classification. So your text file turns into a database in GIS. This is a layer file where the geometry is saved, so that's the polygons for our zones. And this is the symbology that's saved in the layer file. And then it gets output as a KMZ. KMZ is KML, KMZ, any type of file you're pulling into Google Maps or Google Earth that's getting exported. So when it's exported, then it can just be overlaid onto the map like any other layer that we have on our aid map. So this entire process runs every hour. So it is changing constantly. During an event, if it's not something that you pull up the next day and check. It's real time, it's live, it's using rainfall data, it's using the numerical models, and it's meant for helping in the decision support and making decisions during an event. Other than on the map, in our weather outlook, there's a flash flood potential. You can see that it's on the table, but we're trying to move from the table to more of a visual way of displaying the data. So it's not in beta testing anymore. I've taken that off, and this is just another example. If you're looking at this, the Aguila, Upper Centennial, higher threat than down in Gila Bend. And also you can click on any of the zones and get additional information, and that's the quantitative preset forecast, the QPF, 1 hour, 30, 10 minute, and that is coming from the QPF program. Okay. These are some examples of how we used it last year. We used social media to relay the message of where higher areas of flash flood potential could be. This is our Twitter and Facebook. You can see, you can overlay the rainfall totals on top of it. So you can tell 6 hour, 1 day, 2 day, 3 day rainfall. So that's helpful too. And also, ABC 15 did a story on this product, which was great, because we think it's very helpful. This tool is available on the mobile map. So if you're on your cell phone and it opens up the mobile version, you just need to go to layers, and it's flood potential. So that if you do open the layers, you just make sure you close the box, and this is what it would look like if there is no flash flood potential. So that's what it would look like today. It has a small outline around it, and if there was something going on, then the zones would get, they would change color. On this, since we're on the layer section, I also added other Arizona one-day rainfall totals. If you click on Pima County right now, it's not going to show anything. They just changed their URL, and I'm getting the new link from J.E. Fuller very soon, before July 1. But you can look at Pinal County and Yavapai County. This is showing 1 day, but if you click on any of the markers, you can get the different rainfall intervals. So that's helpful if you're traveling, if maybe you live in Tucson or coming through Pinal County. So that's a fun little upgrade. Okay, where do we see our stream flow? So we have our rainfall markers colored, and we have done a great job on the historical data. So we started thinking, how can we improve the stream gauges? So this, we have 202 water level sensors and 132 stream gauges. So this is, it's the Streamflow data set on the map. So we see a need to improve the way that Streamflow data is displayed on the aid map so it's more meaningful, because we know what all of these numbers mean, but we could make it better. So let's look at how we think, how we're going to do this. I'm going to look at Powder House Wash versus Hassayampa River at US 60. So these are both stream gauges that are in Wickenburg. This is the 60. This is the Hassayampa River. And then we have our Hassayampa US 60 gauge right here. And then we have Powder House up here. So these are they're less than a mile apart if you measure the distance. But if you go on Dave's Streamflow page and look at your flow frequency, the 100-year flow at Powder House Wash is 1,900 CFS. But if you look down at Hassayampa US 60, the 100-year is 71,000. So that's a huge difference. So on our map right now, you would see the number in CFS, but what does it mean? So what was that flow frequency I was just talking about? The flood frequency is the concept of the probable frequency of occurrence of any given flood. So the analysis relies primarily on consistent records and are represented with point observations, so your streamflow observations at a particular point. The data can come from FEMA, flood control, or other historical data, and the longer the record, the better. So I'm just going to show these couple products that we're working on for Cave Creek, near Cave Creek, and it just kind of shows, here you see the feet, that's going to be feet in the stage, and then you see the years. So you can see there's a relationship between there. And then this is one of our current conditions products. Because we have this curve, we can estimate the recurrence interval in real time also. So those are things in the future. So who's kind of doing this already? USGS is. If you look at their maps, there is a color coding on their stream gauges that show low to high, and it's just showing what's above normal stream flow. So your eye kind of goes, okay, blue is much above normal. I need to be looking at the blue ones. Those are more areas of concern. So all streamflow data is still going to be on your streamflow data set, but we want to change the background color of the markers. So the markers will change color dependent on the hydraulic activity at the particular stream gauge. The numbers on the markers will still display the CFS, and your info windows will still get you to all the additional information, your streamflow page, your decision support, and your current conditions graphic. So here's an example, same two gauges, Powder House and Hassayampa US 60, right here. I'm going to zoom in to that, and you can see this legend in the upper right hand. So I took the event from July 18th at 3, and just pulled the streamflow data off of there. During that particular event, Powder House Wash showed 2,300, and US Hassayampa showed 9,000. So if you're looking at those numbers, it looks like Hassayampa had more water. We should look at that. But Powder House Wash was actually more of a had more of flood threat, had a higher CFS for that particular location. So in the new layer, it would show that Powder House would be red, and Hassayampa US 60 would be orange. So you would know to look at the red one first, and it may be more of an issue. And this, you can still click on the markers and it'll show. So we're hoping it will be easier for the end user who is not familiar with each individual stream gauge location to know which locations are experiencing above normal hydrologic activity. So I hope you like the products. Do you guys have any questions about the map or any of the layers? Okay, with that, Daniel Henz is up, and he'll pull his presentation up.
I just want to make a quick comment too. I've noticed that there's been some questions that have come in through GoToMeeting on the chat section. We'll address those questions when we get to the open discussion at the end. So if you're still on here, don't worry, we will get to those. So I want to talk a little bit about GovDelivery before we get into our 2016 Monsoon Outlook. And basically this week marks our 1-year anniversary since going live with GovDelivery. And it's been a great success. We've been able to revamp most of our forecast products involved with the Meteorological Services Program. We've been able to add user customizations for you guys, the end users. And like I said, I've got a lot of good feedback on it. And ultimately, from our end, it's saving us time, especially when it comes to issuing weather statements. And I just want to take a few seconds to show some of the new changes for this year. So let's start with our message statements. So these are message 1, our update, message 2, flash flood watch, or message 3, flash flood warning. What you're looking at on the left here is kind of what our GovDelivery email message looked like last year. You know, our same comments section, different available links, and then our table that we were using that listed all the forecast zones, and then we can put our valid time and what's going to be affected. So what we're going to be doing this year actually is we're going to get rid of that table. We started doing this a little bit last year at the end of the monsoon season with some good success, and so we're going to continue it on. And we're moving towards more of a new graphical interface where we can actually highlight the zone on top of the Google map, as well as display information like radar, the current radar image, highlight areas of particular concern within a forecast zone. So on this example on the right here where you're seeing Phoenix South forecast zone, under a message here, we can actually highlight in green some areas within the zone that might be affected more than others. As far as the comment synopsis section of listing out rainfall potential or washes that might be impacted, all that's going to stay the same. But again, we want to give you guys a better visual interpretation of what's going on as opposed to using that static table. This product's going to be available, like I said, in all of our message statements. So that's, again, our alerts, our watches, our warnings, and even when we issue the all clear sometimes after event ends. So we did not forget our lake alert. Same kind of setup as last year, where we have, again, our comments, and then using that table highlighting which lakes are going to be affected as storms have been. We're going to remove that table, and we've actually created new polygons around all of the lakes that are part of the program. And again, as we issue one of these lake alerts, you'll see a graphical image. It'll highlight the lake. It'll have the valid time. And again, the discussion won't really change on there. But like I said, the overall ability to view what's happening and the ability for us to overlay other information such as radar, rainfall, streamflow, any of that is all available now. So hopefully that you guys will like that. Okay, so as far as our weather outlook and with the lake alerts, if you're not receiving lake alerts now, the easiest way to go about signing up for them is just to pull up any one of the weather outlooks that we send out daily. You can actually just click on that button that's being highlighted there, click to sign up, and it'll take you to the subscription page. There you can just enter your email address, hit submit, and it'll show up on your subscription topics, and you're all set to go. So really, really easy way to sign up for lake alerts. Now, we get lots of questions from a lot of your users that you have new people that start out within your individual agency, and you want to get them added on to the weather outlook list. So the easiest way for you guys to do that is just go to the FCD.Maricopa homepage, and on the bottom left there under the current weather, just click on the weather outlook button, and we've actually added a hot link button to be able to sign up and subscribe to the weather outlook. You can see it's just to the right there. I'm highlighting it. When you click it, it'll take you again to that same subscription service page. Just enter in your email address, hit submit. It'll have you confirm your email address, and you're all set to go. So our next question that's been coming up now is when we get into weather statements. So as far as being able to sign up for specific weather statements, again, our watches, our warnings, our alerts, that's something where you still need to send an email into someone here at the flood warning branch team. But what we're doing now with this is we're really trying to focus in on sending you the products that you need. And the way that we're doing that is giving you the ability to select which forecast zones you want to receive those messages from. So if we're starting from our subscription service page, you're already on the list here. You can just type in your email address. You hit submit there, and it's going to pull up your subscriber preferences. And what we have you do is if you head on over to the questions tab on the right there, by clicking that, it's going to pull up a page that's going to give you a question saying in which forecast zones do you want to receive the updates. You can go ahead and select or deselect any of the forecast zones that you're interested in. So as it's set up now, I would be receiving all of the weather statements for all of the zones. Let's say that you work in Scottsdale and you just want to have Scottsdale North and South. You can just select those, unselect the rest of them, and you won't be bombarded with emails when we have a widespread rain event. I know this was a huge problem back in the past, you guys getting tons of emails, having to sift through what you really want. This should hopefully help clear that up and, again, make the information more meaningful to you guys. Again, yeah, after you make your selections, don't forget to hit submit, and you're all set to go. So one thing I wanted to talk about now, too, was the ability for having text alerts. So GovDelivery allows us to send out a text link to your phone, and you can see examples of this over on the right, whenever we issue a message or a lake alert. And so we did this last year with some limited partners. MCSO was one, and some of the other O&M folks here at Flood Control. And they ended up really liking the service in that sometimes they may not be in front of their work computer, they may not have their work email in front of them on their phone, but if you get a text alert, the information's right there at your fingertips. So we're going to make this service available to all of you, and that's for anyone that's already a part of our weather statements list. So this isn't open to the public. Our weather statements have never been sent out to the public, but anyone that's on that weather statements distribution list can actually sign up to get text alerts. And all you have to do is send myself or anyone else in the flood warning branch an email saying that you wanted to get added, and you'll start receiving those. Also wanted to let you know that if your carrier data rates, they'll all apply. So if you don't have an unlimited texting service, you may or may not want to do this because, again, every time it sends a text, it's going to count against your quota. So if you have unlimited texting, you're all good to go. So as far as GovDelivery, that's all I really wanted to talk about. Does anyone have any questions in regards to any of the information I just covered there? All right, let's move on to the outlook for the monsoon. As we get started here, I just wanted to kind of say I think this is really fitting. We are a week away from the start of the actual monsoon season here on June 15th, but we're actually in a unique pattern right now where we're going to get a kind of a monsoon preview or taste of the monsoon starting later this evening for folks that live across southern Arizona, and then tomorrow across all of south central Arizona and even central Arizona, and we could see some blowing dust and storms. So it is kind of fitting when we talk about this. Mother Nature is complying, and it'll be fresh in your minds. So let's start off with just some quick basic information. When is the monsoon? As I mentioned before, the season officially starts on June 15th. It ends on September 30th. But as many of you or all of you that live around the desert area here know, that the actual onset, when we actually get enough moisture for storms across the higher terrain and even in the lower deserts, usually comes around July 7th for the Phoenix area. And a typical end is usually in the first week in September. So it's also worth noting that every year, the onset and end dates, they can be earlier by a few weeks or even later by a few weeks, and also depending on what part of the state you're in. So that kind of all comes back to why we've just created this official season range from June 15th to September 30th, just to kind of get everybody on the same page. So as far as rainfall stats here in Phoenix and at the Phoenix Sky Harbor Airport, your average season rainfall is just under 3 inches, about 2.71, and that makes up about 30 to 40% of the yearly total. Wettest season, just above 9.5 inches, back before driest season, just over a quarter inch, way back in 1924. And then on any given season, we're looking at about 11 days with rain at the airport, and that's just looking back since 2000. As far as last year, we had 3.29 inches of rain, and ultimately it was reported as a wet monsoon season. But I guess that kind of depends on your perspective. So that value, again, is coming at the airport. But if we take a little bit more complete look around the county, what you're seeing here are rainfall totals for the 2015 monsoon season from all of our alert rain gauges, and you can see those highlighted in black. As far as the color coding, the greens denote lower totals, and then as you move into the yellows, oranges, and reds, and you go into higher totals. And I just wanted to kind of point out here, our two main areas in these polygons, these are the areas where rain gauges receive 3 inches or more of rain, which is the average what we get when we take all rain gauges combined during the monsoon season. And as you notice on here, the airport happens to be in one of the favorite spots along with parts of South Phoenix and maybe even Tempe and a little bit of Chandler. And of course we had our significant rain event on the 18th of July up in the Wickenburg area. But for anybody else, last year was kind of a really bad season in terms of rainfall. Much of the county and much of the Phoenix urban corridor was below average to well below average. So in terms of your perspective, yes, it was wet at the airport, but it was really dry as a whole. If we kind of look at all of the gauges averaged, again, our mean total, which we typically see, is around 3 inches. You can see 2015 on the far right here. We actually only got just over 2 inches, or about 72% of normal for the entire county. So with that, let's move into this year. So here you're looking at the Climate Prediction Center's 3-month outlook for this upcoming summer, and that would be July, August, and September. And these are 3-class forecasts. And so what that means is they're giving probabilities of above average, or excuse me, above normal, normal, or below normal temperature and precipitation. So as far as temperature, CPC is calling for a 57% chance for above normal temperatures, 12% for below, and 31% being around normal. So favoring this warmer than average summer season. In terms of rainfall, unfortunately we're getting these equal chances for above, below, or normal. And that's something that's kind of typical during the monsoon season, just because larger scale features are much harder, or don't necessarily come into play as much as smaller scale features for the monsoon season. So trying to make a prediction this far out and for an entire 3-month period isn't usually as relevant. But what we're going to try and do is kind of delve into some of the main features that we might typically see and see if we can pull out some more information from that to try and gauge where we're going to be. So before we do that, I want to just do a quick refresher on the North American monsoon in general. And basically, all the monsoon is it's a shift in the wind pattern. So typically what we see during the fall, winter, and spring are generally westerly flow, so west to east, or northwest to southeast. Now as we transition into the late spring and summer, flow tends to move more out of the southerly or southeasterly direction. The main mechanism behind that, so we call our monsoon ridge, and during the month of June into early July, the monsoon ridge progresses north into the desert southwest and promotes southeasterly flow at mid and upper levels. So we're getting moisture pulled in from Mexico and even the Gulf of Mexico. And then intense heating across the Mojave Desert and Sonoran Desert also lends to a thermal heat low, which can help pull moisture north out of the Gulf of California and even the Pacific. And as soon as we reach the right amount of moisture, we start to get daily thunderstorm chances across the higher terrain. And if we're lucky enough, we may even get thunderstorms down in the lower deserts and in the valleys if we have triggering mechanisms. So let's start off here with El Nino, because it's everybody's favorite topic. We just experienced one of the strongest El Ninos on record this past winter, and it's actually significantly weakened up to this point in the spring. In fact, I just got an email this morning from NCEP CPC saying that we are officially no longer in El Nino conditions and we have moved into end zone neutral. And so if you look at the diagram on the top right, you're looking at sea surface temperatures across the equatorial Pacific, and you can see we go from above average sea surface temperatures and then trending towards these cooler temperatures across that equatorial Pacific, which is more of a signal towards neutral and possibly even moving into La Nina conditions. And as we look at the image below, the probabilistic forecast, CPC is also basically stating that we are moving into neutral conditions, and we're there now, and potentially trending towards La Nina, which becomes the favored signal as we move into late summer, fall, and into the upcoming winter. And so overall, the El Nino climate signal isn't a huge strong factor, especially in terms of rainfall or even temperatures so much during the monsoon season, but it does have an effect. And so I want to try and kind of help show this here. And what we're looking at are box and whisker plots showing precipitation during the July, August, and September period for Climate Division 96. And if you look in the top left, Climate Division 96 here makes up all of Maricopa County, basically south central Arizona, parts of central Arizona, and southwest Arizona. And so to kind of understand these plots here, we have precipitation across the y-axis, and then we have the conditions. So we're in El Nino, neutral, or La Nina conditions for that particular year. And what we have here, again, is our box and whisker plot. The red line denotes the 50th percentile. So half of the years fall below that line, and half of the years fall above that line. That's basically our average, given a particular event, whether it's El Nino, neutral, or La Nina. If we go to the edges of this blue box here, what you're looking at on the bottom is the 33rd percentile and the 67th percentile. So for this bottom one, 33% of the events all fall below the bottom of that box, and above this one here, 33% of the events actually lie above that. And then as we move out into the whiskers, we get to the 10th and 90th percentiles. Long story short on here, basically any of the seasons that fall within this middle box are basically around normal conditions in terms of rainfall. As we extend up into the the whiskers on either side of the plot, you get to below normal, which would be below the box, or above normal above the box. And then if you extend past the whisker, you get into those much above normal to record wettest or much below normal to record driest. And ultimately, these distributions are fairly similar. What we're seeing is on Enso neutral and La Nina years, the slight tendency towards more variability and slightly wetter conditions. And then with El Nino, a little less variability and slightly drier conditions. But overall, the signal's not very strong, and we've kind of emphasized this the last couple of years. And but what I would like to do now is focus in on the monsoon ridge itself, kind of the main catalyst that drives the monsoon here. And so what you're looking at is I'm going to show a series of 500 millibar height images, and monsoon ridge gets denoted in those areas with the higher height. So if we look kind of in the center here, this red area of higher heights represents the monsoon high. So I've gone back and looked since 1980 at a bunch of the different years, and what you're looking at here is neutral years. So again, no El Nino, no La Nina, kind of normal conditions, and we can see the general placement of the monsoon high happens to be right around the Arizona-New Mexico border, and that's actually lending to southeasterly, southerly flow at mid and upper levels, and this is actually more of a favorable pattern, at least in terms of setting up the large-scale atmosphere for getting thunderstorms. Now, if we want to switch to what we experienced last year in 2015 with the developing strong El Nino, as well as what we saw back in 97 and in 1982, so our three strongest El Nino patterns over the last 20 years, more than that, 30 years, we can ridge has actually been shifted further to the south and to the east, with the center being more along the Texas-New Mexico border. And why that's kind of important is the large-scale pattern, this kind of favors more southwesterly mid and upper level flow, a little less conducive for seeing storms, or at least the pattern for seeing storms across the lower deserts. And as you can remember, there weren't all that many storm days last year. This is also important too, because the strength of the ridge, the stronger the ridge, the better chances for warmer temperatures. So what I want to do now is go into what would be a transition, so kind of what we're expecting to experience heading into this monsoon season. What you're looking at is July through August of 1983 as well as 98, so after the last two big events. And we can see that that ridge center has actually shifted farther to the north and actually extends out into the southern plains. And this is a pattern that, again, is more favorable for having this southeasterly to southerly flow across Arizona. And this actually kind of comes in line to one of our classic large-scale setups in terms of seeing severe weather and extra rainfall type days across Arizona as a whole. I want to note that even though you're seeing these composites of where the monsoon ridge is for that July and August period, it shifts around all the time. It doesn't stay in the same place. The ridge may shift across the Great Basin. It may sink farther south into Texas or in the southern plains. It moves around. But ultimately, what we'd like to see is this ridge somewhere near the Four Corners or southern plains area as a whole over that period to have a good shot at maybe seeing a wetter season or having favorable conditions for storms. And we can see, again, that 2015, our last year, on these strong El Nino years with having the ridge shunted further to the south, it's a little less favorable. I will note that this can make for a very volatile combination, especially as you head into September when we reach peak hurricane season, as well as when we start to get cutoff lows in the area. Having that low shifted, or excuse me, the high pressure area shifted further south can help pull moisture in from tropical systems or allow these upper level disturbances to move across the area, and we can get some pretty significant rain events like what we saw even back in 2014. So, but during July and August, this isn't what we typically like to see. So, we're now moving on here to sea surface temperature anomalies across the entire globe. And there's a few features on here I'd like to point out. First, you can see across the equatorial Pacific our weakening El Nino transitioning towards neutral / La Nina conditions. And also, we still have this signal of a positive Pacific decadal oscillation. So you're seeing a cold pool of water across the North Pacific, and you're seeing warmer than average sea surface temperatures from the Alaska coastline down into the Northern America. And why I kind of wanted to bring this up is looking at previous research done after the North American Monsoon Experiment and some of the work even before then, that cold pool tends to favor the establishment of the ridge across the Great Plains during the summer season, higher heights. And when we have that, we typically tend to see our wetter seasons across the desert Southwest. Not always a guarantee, but it's a good sign. So now I want to kind of focus in on the Gulf of California right here. We can see the southern half of Gulf of California. We're seeing warmer than average sea surface temperatures and then near normal temperatures as you move into the northern part of the Gulf. And so I can pull up the actual sea surface temperatures as of the end of May, and we can see this cooler temperatures farther north with these warmer waters farther to the south. And the reason I bring it up is that a lot of the research has shown is that actually 80% of the rainfall that falls during the summer across Arizona and New Mexico does not occur until after the northern Gulf reaches 28.5 degrees Celsius. You can see right now the average temperature is somewhere in that 23 to 25 degree range, and so we're not quite there yet. But we're warming fast, and we're entering the period where those waters across the central and northern Gulf start to warm rapidly. So we are getting close. Okay, so I want to look now at our winter rainfall from last year. And again, what you're looking at is the rankings in terms of precipitation during the December through March period. Again, this is for this previous last winter. Unfortunately, we did not get all those rains we were hoping to see from our El Nino conditions, and it was actually very dry, below normal and much below normal across the entire desert Southwest, southern Rockies, and southern Utah, and even into California. However, you can see in the Pacific Northwest, a lot of rainfall, much above normal conditions, even some record wettest conditions. And the reason I wanted to kind of bring these up as well is, again, according to some of the previous research, some of our wetter monsoon seasons are typically preceded by dry winters, as well as wet winters across the Pacific Northwest. Some of the logic behind that is lower snowpack amounts across the southern Rockies and southern Utah, and soil conditions can help move the monsoon ridge further north faster, again, potentially setting up favorable conditions to see rain in the desert Southwest. So lastly, I wanted to just quickly talk about our wild card every year, which is the hurricane season, the East Pacific Hurricane Outlook. Last year was pretty significant. It was the second most active with 26 named storms, 16 hurricanes, 11 of which were major. That animation behind which you can see is actually of Patricia, which was the strongest hurricane in the Western Hemisphere that we've ever seen, and it was also the strongest landfalling hurricane in the Eastern Pacific. So pretty impressive storm in October there. But as far as for 2016, the Hurricane Center is expecting more of a normal season, so something along the lines of 13 to 20 named storms, 6 to 11 hurricanes, 3 of 6 expected to be major hurricanes. I just wanted to point out that, again, it only takes one, or it even takes the assistance of one. The actual remnants don't have to move into the desert Southwest, but if we have the right ridge placement, we can pull that moisture north, and it can aid in thunderstorm development and subsequent rainfall. So kind of pulling this all together here, NOAA CPC forecast is expecting above normal temperatures, equal chances for above or below normal precipitation. As usual, it's always a complex forecast. It's almost like throwing darts at a dartboard. But reason for optimism would be some of these larger scale predictive factors in regards to the monsoon ridge and its placement. It looks like there's, a good shot at we could see a normal to possibly even a wet monsoon if we go on those alone. I want to emphasize again, it only takes a few heavy rain events to reach our monsoon rainfall quota at the airport or overall as a whole across the county, especially if we see any widespread significant events like we saw in 2014 or perhaps like what we saw in Wickenburg last year during July. And it's also important to note that, again, any location in the Phoenix Valley or the urban corridor is subject to flooding or flash flooding if enough rain falls in the right amount of the period. So now is the time really to prepare, and we've got all sorts of information available through the Flood Control District as well as the National Weather Service, and you'll see plenty of information on the local news broadcasts. I'll move on to questions at this point, and I'm also going to just leave this slide up here that just shows how you get to some more of our information. But any questions, I'd be happy to take them now.